First, open the Microsoft Excel in your computer. Go to File, select Option, select Add In, select Manage, Excel Add-in, select Go, choose the Solver add-in, and OK. Then, key in the data according to the question. The questions are shown as follows. First, key in the variables. X1, X2, and X3. Next, key in the objective function. Min equal to 3x1 plus 2x2 plus x3. Then, for the constraint, it must consist of left-hand side, the inequality of constraint, and also the right-hand side. Next, for the left-hand side, insert the data according to the constraint 1 in the question, which is 90x1 plus 20x2 plus 40x3 greater than or equal to 200. After that, repeat the step for constraint 2 and constraint 3. For constraint 2, 30x1 plus 80x2 plus 60x3 greater than or equal to 180. For the last constraint, which is the constraint 3, 10x1 plus 20x2 plus 60x3 greater than or equal to 150. Don't forget to insert the non-negativity constraint, which are x1 greater than or equal to 0, x2 greater than or equal to 0, and x3 greater than or equal to 0. To solve the problem, go to Data, select Solver, then a box of Solver parameter will show up. In the Set Objective box, click on the objective min. Then, choose min, because our main objective is to minimize cost. In the By Changing Variable cells, select the three variables. Then, click the Add button to add in the constraint. Add constraint box will pop up. Since all the inequality for all the constraints are the same, we can just drag the item at the left-hand side into the cell reference box. Then, for the inequality column, choose greater than or equal to. Do the same for the item at the right-hand side for the constraint box. Then, click OK. The box will show as follows. Afterwards, select a solving method. Simplex LP, solve. Then, the solver result box will pop out, and for the reports, select all as shown in the screen. Then, select OK. The answer will be processed and shown as follows. Now, let's see few questions related to sensitivity analysis. For the first part, let's see on the changes in right-hand side. Roman 1. If the minimum daily requirement of carbohydrate are reduced by 50 kg, what will be the new cost for it? The changes related to the first constraint. So, we will focus on the first constraint. Since the minimum requirement is still within the range for allowable decrease as shown in the table, hence, the new feeding cost is as follows. Roman 2. Determine the effect of changing the minimum daily requirement for protein plus minus 15 kg. Now, it is related to the constraint number 2. So, we will focus on the second constraint on the table. The changes is still within the range. However, the dual price for the protein is RM0. Hence, there will be no effect in the feeding cost if we plus minus 15 kg. Now, let's see question on the changes in the objective function coefficient. Roman 1. If the cost per kg of corn is reduced to Rm 2 ringgit and 60 cents, what will be the new solution? This question related on the changes in the objective function coefficient for constraint 1. For changes in the objective function coefficient, we will refer to variable cell table. So, focus on the first constraint. We can see that the changes is still within the range because the changes is reduced to Rm 2 ringgit and 60 cents from the original price, which is Rm 3 ringgit. Hence, the difference is 40 cents. However, the new solution will remain the same because the dual cost is 0. Roman 2. If the cost per kg of alfalfa is increased by Rm 1 ringgit, what will be the new solution? Since the alfalfa is the third constraint, so in the variable cell table, we will refer to the X3. Based on the table, the increase in cost per kg of alfalfa is not within the range. Hence, the changes will not keep the current solution optimal. Therefore, further calculation is needed.